Okay, one of the first things we did in class today was review air pressure and how air pressure can be affected, especially by temperature and density. So as we're looking at air pressure, one of the demonstrations that we did do in class is by putting a hard-boiled egg on top of a glass bottle, and by then adding some heat in the terms of a burning piece of paper, it's going to then warm up the air inside. And as we warm up the air inside, you're going to notice that the egg there kind of wobbles or wiggles a little bit. It's letting that warmer, expanding air out, creating a little bit of a vacuum inside. It's also burning up some of the oxygen in there as well. And while that is creating a little bit of a vacuum, we're getting a low pressure area inside where there's not as much air pressure pushing back on the inside of the egg, and the atmospheric pressure in the classroom is a higher pressure, and that starts to push down on the egg. As that pushes down on the egg, you can see that it is kind of starting to get sucked down into the bottle. You can start to see actually where it's pushing down and actually compressing the egg and trying to fit it into the glass bottle there. And it popped into the bottle. Again, the high pressure of the room pushes the hard-boiled egg into the glass bottle where there is lower pressure. And with the second demonstration that we did in class, we got a bottle, a Gatorade bottle, poked a hole in it and put a balloon over the top. As we suck the air out inside, it creates a little bit of a vacuum, lowering the pressure inside the bottle and allowing the atmospheric pressure of the classroom to then fill up and inflate the balloon. There's nothing there in the way. We can see again one more time as we take the atmospheric pressure out or create a little bit of a vacuum in the room, we can see then that the air from the classroom fills that. Then we took what we looked at with air pressure and we started to then tie that into the concepts of wind and what causes wind. So some of the main things that we looked at for causing wind are differential heating and cooling, the effects of energy transfer. As heat transfers to and from the atmosphere, different parts of the Earth's surface are going to heat up and cool off at different rates, creating different temperatures and leading to different pressure air masses. For instance here, as warm air expands, it becomes less dense, and cool air is going to be denser and heavier. Warm air is going to rise, and sinking cool air is going to produce convection currents. So again, that cycle between warm air rising and cool air sinking, which we talked about a few sections previous. The denser air is going to produce high pressure systems, and less dense air is going to produce low pressure areas or low pressure systems. Okay, and most importantly here, as we tie all these different individual concepts together, we're going to be looking at the difference in atmospheric pressures causing air to move or creating wind. And again, wind is always going to be moving from areas of high pressure to areas of low pressure. So that difference in atmospheric pressure is the reason that wind or air is going to move across the surface. And again, wind is going to be air moving across Earth's surface. So kind of our definition of what wind is. Then we started to look at the different types of wind. We got a worksheet that looked like this. It had local winds on it. One of the first things that we went over was a sea breeze, where we're looking at a beach area where we have the ocean meeting the land, and we also have a diagram of that. The diagram of that right here is going to show the warmer air over the land heating and rising, creating a low pressure area over here, and then cooling and descending and creating a high pressure area here, and then the wind is going to move from the sea towards the land, and that's why it's a sea breeze. Next, we're going to have a land breeze, and with the land breeze, whoops, with the land breeze, we're going to have the opposite happen. Okay, and even going back to our example here with a land breeze, we're going to have the complete opposite at nighttime. The water is going to be a little bit warmer, so we're going to get warm air rising over the ocean water. It's then going to cool over the land, and because sand and soil cool off very fast, at night they will then end up cooler than the water in some places, and that's where we'll get this land breeze. And then the high pressure area would be over the land, and the low pressure area would be over the water, and we would get the wind moving from over the land then towards the water. And we have that here in the example as well. One of the next things we looked at was a valley breeze. In this case, we're looking at a mountainous slope, and in the daytime, we're going to have the sun heating up the air, and it's going to be rising out of the valley up to the top of the mountain. And looking at a little bit more animated picture of that. Okay, warm air rising being less dense, and a low pressure area at the top of the mountain, and the denser high pressure area at the bottom in the valley. So we're going with the wind from high pressure to low pressure. Okay, again, high pressure to low pressure. And the last thing that we looked at was a mountain breeze, and that's the opposite of the valley breeze, where we have, again, nighttime, and we have the high pressure on top as the air cools off during the night and sinks down into the valley. And we looked at our animated graphic for that one. Again, our high pressure system or high pressure area up in the mountains, and then the cooler, denser air would start to sink down into the valley where there's going to be lower pressure. So again, wind moving from high pressure to low pressure at night, sinking down from the mountain into the valley. And one of the last things that we did was read the article Where the Wild Wind Blows. And we read through that article. There were some questions at the end. What causes low pressure regions that prevail over the tropics, and what causes local winds to blow from the sea into the land? Looking at those different questions here, we have the first one with the low pressure regions over the tropics. Earth's surface at the tropics receives more solar energy than other areas north and south of the equator. Thus, more heat is going to be transferred to the air above the tropics than to the air north and south of the tropics. Warm air expands and rises, or is pushed upwards by the cooler air that's replacing it. And because it is less dense, that's why it's going to rise. The less dense air pushes with less pressure, producing a low pressure area at the surface of the Earth. With the second question, what causes the winds to blow from the sea onto the land during the day? During the day, the land warms up more, has a higher temperature than the sea. Air over the land warms, expands, creates a low pressure area, and the cooler air over the sea creates a high pressure area. The cooler, denser air over the sea flows under the warmer air, causing the warmer air to rise. The movement of the air from sea to land creates the sea breeze, like we looked at with the diagrams earlier. Again, if you have any other questions about wind blowing and air pressure, please ask in class.